Okay, this is the second question. Here also they gave these are bijections and we have to show this. They both are equal. Okay. Now, see, if f function is a to b, then f inverse function will be b to a. If g function is b to c, g inverse function will be c to b. Okay. So, let us consider A belongs to A, B belongs to B, C belongs to C. Okay. Now, this one. G circle f of A. G of f of A. What is f of A? See here. F function is A to B. So, f of A will be B. So, A will be f inverse B. G of B is equal to C. So B will be G inverse C. This is first equation, this is second equation, this is third, and this is fourth equation. Okay, so here G of f of A. What is f of A? F of A is B. What is G of B? C. Means G circle f of A is equal to C. Means A is equal to G of f whole inverse C. Okay. Take it as fifth equation. Okay. Now f inverse circle G inverse of C means f of G inverse C. F inverse of G inverse C. What is G inverse C? B. What is F inverse B? A. Means F inverse circle G inverse C is equal to A. This is sixth equation. From fifth and sixth equation, see, they both are equal to A. Means they both are also equal. Means G of f whole inverse C is equal to F inverse circle G inverse C. If we cancel, G circle F inverse is equal to F inverse circle G inverse. Okay. We have to prove they both are equal and we have proved. That's it. Now we'll dive into the third question. See, here they both are identity functions and this function is a to b. Okay, identity function means input and output will be same. Means IA is a to a function and IB is b to b function. Okay, F is a to b function. Means f of a is equal to b, input is a, output is b. I of a is equal to a only because input and output are a only. I of b will be b only. This is first equation, second and third equations. Okay, now f circle IA of a means f of IA of a. What is IA of a? A. F of a is equal to b. Okay. Now IB circle f of a. Here IB of f of a. What is f of a? B. IB of B. What is IB of B? B means f of IA of A is equal to, we can say it is f of A, right? Yeah. See, f of A is B. So we can say this is equal to f of A. Means IB circle f of A is also equal to f of A. Means f of IA is equal to f is equal to IB circle f. Completed. See here, f function is A to B. Means f inverse will be B to A. Okay, here IA and IB are identity functions. So input and output will be same. IA and IB same. Means f of A is equal to B. A is equal to f inverse B. Here IA of A is equal to A. IB of B is equal to B. Okay, now we'll take this first. F of F circle F inverse of B is equal to f of F inverse of B. What is F inverse B? A. F of A is equal to B. Okay. Here B is equal to IB of B, right? We can say IB of B means f of F inverse B is equal to IB of B. Okay, now we'll take this one. F inverse of F of A. F inverse of F of A. What is F of A? B. What is F inverse B? A. Means F inverse circle F of A is equal to, what is A? IA of A is A. We have to prove that they both are equal. We have proved it. We have to prove that these two are equal. We have proved it. That's it. Fourth theorem is also completed. Now we'll go to fifth one. See, there is a very rare chance that we get this question, because in the history of Telangana only one time we got this question. Okay, but there is a chance that we can get this question, because previous year nobody expected that Gauss Jordan method question will come, but it came. So this year also, not taking any chance, will prepare all of the questions. Now see this question. After reading this question, you'll think it is a very hard question, very different question, but it is not like that. It is very easy question. It is based on our previous theorems. If you understood, if you understand the previous theorems, it is very easy to write this theorem. Okay, see, they only gave that if A to B is a function. Okay, now case 1, you have to write case 1. Okay, if it is a bijection, then we have to prove f circle G is IB and G circle F is equal to IA. In this case, G is equal to F inverse. Okay, they only gave this in the question. Okay, now see, since it is a bijection, it is since it is a bijection, F inverse function will also be a bijection, right? See, F A to B is a bijection means F inverse B to A is also a bijection, right? If they are bijections, then we know that F inverse or circle F is equal to IA and F of F inverse is equal to IB. Okay, we have proved this in the previous theorem. See, we have proved it. Okay, there is no need to worry. Have to just remember. If you have understood the question, you can easily remember. Okay, if you are seeing this marathon lecture like a Netflix movie, then no, you can't get it. Take a copy, take a book, put a pen on it and write and solve all the questions with me. Come on. See, now we'll take now take G is equal to F inverse. Then G circle F is equal to IA and F circle G is equal to IB. We have to put G in the place of F inverse. Okay, in the place of F inverse, we have to put the G. Okay, we have just put G in the place of F inverse. Why? Because they gave it in the question. Okay, now case 2. Let's assume there is a function G B to A. Okay, in case 1 we are saying that we are assuming that there is no function, but in the case 2 we are assuming that there exists a function. Okay, then G circle F is equal to IA and F circle G is equal to IB, and we have to prove F is bijection. We have to prove this. Prove this, it is a bijection. Okay, and G is equal to F inverse. Let this one, I think you know, A1 A2 belongs to A. F of A1 is equal to F of A2. Okay, here F of A1 and F of A2 belongs to B. Then G of F of A1 is equal to G of F of A2, means G circle F of A1 is equal to G circle F of A2. What is G circle F? It is IA, right? Means IA of A1 is equal to IA of A2 and A1 is equal to A2. Therefore, F is 1, 1. To prove bijection, we have to prove it is on 2 as well. Okay. Till here you understood, right? Right? See here, it's very, very simple. First, we have to assume that there exists no function called GB2A. There is no function. And we have to write the fourth theorem result. Okay. F inverse of F inverse circle F is equal to IA. F circle F inverse is equal to IB. Okay. Now in the question only they gave this one, G is equal to F inverse. We have to take it, and in the place of F inverse we have to just put G. Okay. In case 2, we'll assume that there exists a function called this. Okay. If there exists, we have to prove that F is bijection. Okay. To prove F is bijection, we have to prove it is 1, 1 and on 2. To prove 1, 1 and on 2, we'll do all this thing. Okay. We have proved that it is 1, 1. Okay. We have to prove it is on 2. So, let B belongs to B. G of B is equal to A. Okay. Then F of A is equal to F of G of B. See, A belongs to A. Okay. F of A. Here A means this, no? We have put it. Next, F circle G of B. What is F circle G? IB. We'll put IB of B. It is equal to B. Therefore, it is on 2. If it is 1, 1 and on 2, it is bijection. Right? Bijection function is irreversible. It is bijection and irreversible function. Okay. If F of A to B is bijection, F inverse B to A is also bijection. Correct? G and F inverse have same domain. So, let B belongs to B since F of A to B is on 2, F of A is equal to B. F inverse B is equal to A. Okay, now G of B is equal to G of F of A. It is G circle F of A. It is IA of A is equal to A is equal to F inverse B. Therefore, G is equal to F inverse. I know it is difficult, confusing, but only this problem in functions is confusing. Other problems are way more easy than this. So please learn this. See, this is the sixth theorem. Here they gave that f a to b and g is b to c and g of f is a to c and g circle f is a to c. How we can say that? Because c b to c, and what is f function? A to b. Okay, here b will cancel and it is a to c. First a came, c. Before arrow a comes, so we have to put it before arrow. Okay, h. What is h? C to D. Okay, then H circle, G circle F is C. H is C to D of what is G circle F? A to C. Will cancel C before arrow A comes, so it is A to D. Okay. Now H circle G is B to D in the same way. Then H circle G whole circle F is A to D in the same way. Therefore, H circle, G circle, F and H circle, G circle F have same domain A. See, here also A comes A. So they both have same domain. Okay. Then let A belongs to A. Then H circle, G circle, F of A is equal to H of G circle F of A. It is H of G of F of A. Here F of A will is equal to B. See, F of A is equal to B, G of B is equal to C, H of C is equal to D. Here input is A, output is B, input is B, output is C. Here input is C and output is D. Okay, you know, right? Now, what is F of A? It is B. What is G of B? It is C. What is H of C? It is D. Okay. Now, H circle G, whole circle F. Here, H circle G of F of A. Here, what is F of A? It's B. H of G of B. What is G of B? C. What is H of C? D. C. They both are equal to D. Means they both are equal. So we can write from equation 1 and 2, we can write H circle whole G circle f of A is equal to H circle G whole circle f of A. We can remove A and we can write H circle G circle f is equal to H circle G whole circle f. That's it. Now theorems are finally completed.